All right, let's look at example 17. And I have like, try that on your own, but let's go through that together. So piecewise functions we work with a lot. And the only thing you have to be aware of is that when you're looking at a piecewise function and you're going to a limit that's right where the function changes how it looks, you're going to have to check from both sides. Okay, so here's how I'm going to do this. I'm going to rewrite this as the limit as x approaches 2 from the left of h of x. And I'm just going to leave it as h of x. I don't want to write all that in there. Okay, well, if I go from the left-hand side of 2, that means that I'm going less than 2. And it tells me if I'm less than 2, I should use this equation right here. And I'm going to do direct substitution. So I'm going to do 2 squared minus 4 times 2 plus 7. Let's see, that's 4 minus 8, negative 4 plus 7. That's 3. Now I'm going to do the limit as x approaches 2 from the right. So as I'm coming from the right, I'm doing values of x that are greater than 2 right there. And don't worry that it doesn't say equals, because we don't really care what's happening at 2, just as we're approaching 2. So I got to use the bottom one, and I'm going to do direct substitution. So negative 2 squared plus, and watch how that negative is showing up. A lot of times I'll get students that'll put that negative inside and then square it and make it a positive. If that would be true if there were parentheses like that, but there's not. So this is saying the opposite of x squared, the opposite of 2 squared. Okay, so that is negative 4 plus 8, that's 4, minus 1 is 3. Okay, so since we have it from the left and the right, and it's approaching the same value, then we're going to say the limit as x approaches 2 of h of x is equal to 3. Ta-da! Now, if they were different, you would say that the limit does not exist. And that is how you do a piecewise.